Hello, my name is Rune Ondro, and this video will be about what I consider to be Albert Einstein's biggest mistake. It is not the gravitational constant that you are most likely to find if you Google this term. What I am to talk about is much easier to disprove than that, and this is Einstein's attempt to explain lift of an airfoil. First, I would like to ask how much of an education is needed in the relevant field in order to acquire enough knowledge to disprove one of Einstein's theories of which there was actually conducted an experiment. I would say a couple of months of physics education should be plenty. This should be enough for anyone to get a rudimentary grasp on Newton's laws of motion and the principle of conservation of energy. And this is basically all that is needed. Einstein presented his theory at a meeting at the German Physics Society in 1916. Einstein held the presidency of this organization from 1916 to 1918, so obviously what he said was very influencing. And this could explain why this theory and variations of it is still around more than 100 years later. There was later published an article that Einstein had written in the German scientific publication Die Naturwissenschaften, which basically means science. This article is called Elementäre Theorie an Wasserwellen und des Fluges, Elementary Theory of Water Waves and Flight. In this article, Einstein claims that a bird or a plane can fly any distance at level flight as long as one excludes the effect of air friction. Einstein explains the way an airfoil produces lift as a function of air velocity over the wing and the corresponding drop in air pressure as described by Bernoulli's theorem, which states that the pressure in the fluid will decrease as its velocity increases. And this is fine as long as this happens inside a closed system and along a streamline. I remember when I was first introduced to Bernoulli's principle. My parents lived in Switzerland for a number of years, where my father studied at ETH, Eidgenössische Technische Hochschule in Zurich. This is a university where Einstein was once employed. My 2-year-old sister was born in Zurich, but the year before I was born, my parents moved back to Norway. When I was 12, my family drove on a summer holiday to Switzerland for my parents to visit their friends from the period they lived there. It was when driving down the German autobahn that my father decided to be a bit pedagogical and started talking about Bernoulli's principle. It might very well be that he came to think about this because we were just to drive through Basel, where Bernoulli lived. In any case, my father tried to exemplify the relations between pressure and the velocity of a fluid by pointing to how the canvas covering trucks tended to billow outwards. This was supposedly because the stagnant air inside the truck would exert a higher pressure on the canvas than the fast-moving air outside the canvas. He also talked about how this produced lift of an airfoil as the air travelling over the top of the wing had to travel along a path and therefore needed to go faster and consequently had a lower pressure. I was immediately a bit skeptical because I really couldn't see that the canvas covering trucks were billowing outwards. It tended to flutter a lot, and I could also clearly see that there were gaps in the canvas covering the trucks. So I asked my father why wouldn't the air inside the truck simply not just escape through the gaps so that the pressure could equalize. The only thing I managed to achieve with this was to get my father annoyed. My father revisited this topic several times over the next years. I assumed that this theory was something he had simply come up with by himself, and I had already found out that one couldn't simply just trust everything he said. My father's theory corresponds to what NASA now calls incorrect theory number 1 on this website. Einstein's theory corresponds more to the incorrect theory number 3, but they are closely related in the sense that they are both relying on Bernoulli's theorem to explain the decreased pressure over the wing. The equal path theory is actually a bit more stupid than Einstein's theory in the sense that the angle of the surface of the airfoil is not considered. Pressure is a force that is always exerted perpendicular to the surface, and it is very obvious that a lot of the imagined effect of the longer path can be shaved off due to the orientation of the surface. How come no one seems to have addressed this? Einstein, on the other hand, imagined that the wing could be viewed as half a venturi, where one simply had removed the upper half. The air would now supposedly be accelerated over the hump due to being constricted by the moment of inertia by the air higher up. Is it reasonable to make this conclusion as Einstein did? Let's consider a venturi where one widens the cross-section. According to Bernoulli's theorem, one simply calculates the velocity and the corresponding pressure to the new numbers. But if Einstein should be correct in his assumption, one needs to believe that at one point it will not matter anymore what width the cross-section has, because one can just as well imagine that the upper part is simply not there. So where is this point? Should it be a sudden transition from one principle to the other, or would it be a more gradual transition? This seems to be quite important. How come Einstein did not seem to have considered this? In 1917, Einstein's principle was tried out at the aerodynamic test station at Göttingen. The director of this institute was Ludwig Pandelt, also known as the father of aerodynamics. It could also be mentioned that Albert Betz, known for Betz's theorem, was employed at the same institute. It should then not be any shortage of competent people who could explain to Einstein that his wing could not possibly work. In addition to being tested out at the wind tunnel at Göttingen, it was also attempted to fit an aeroplane with Einstein's wings. This did not work any better, and according to the test pilot, the plane flew like a pregnant duck. As I said, the only thing that one needs to know in order to disprove Einstein's theory is Newton's laws of motion and the principle of conservation of energy. What one simply can do is to do a thought experiment. Let's think that a glider plane is winched off to level flight like shown here. So then, when the plane flies in according to Einstein's principle, the lift of the airfoil will exactly balance the gravitational pull of the mass of the plane. Then, let's imagine that we drop an object from the plane. This will reduce the mass of the plane accordingly, but the wings will continue to provide the same lift, as it is only dependent on the velocity of the plane, the shape of the wings and the density of the air, all of which nothing has been changed by dropping the object. And as the gravitational pull is now less than the lift of the wings, the plane will start to accelerate upwards according to the function force equals mass multiplied with the acceleration. So then, the kinetic and potential energy of the plane is the same as it was before the object was dropped, minus the energy of the object itself, of course, but this energy has been accounted for as the energy associated with it. But the object was provided by the winch, and the object brought its associated energy with it when it fell to the ground. But as the net force upwards will make the plane increase its altitude, the potential energy increases without any input of energy, which is a clear breach of the principle of conservation of energy. So, of course, Einstein's theory could not possibly work. Another thought experiment one can do is to imagine that one puts an empty box onto a scale. The scale will then measure the weight of the box. If one puts a remote-controlled model helicopter into the box, the scale will then measure the combined weight of the box and the helicopter. The rotor of the helicopter consists of airfoils equivalent to Einstein's airfoils, so that the helicopter should then supposedly be able to hover in the air without disturbing the air and without using any energy, obviously now excluding the effect of air friction. As Einstein claimed that it should be possible to fly without using any energy, it naturally follows that no energy can be used on changing the state of the air, like moving it downwards. So then, if the air inside the box is in exactly the same state, no matter if there is a helicopter flying inside it or not, how can then the scale detect any difference? But gravitational pull from the Earth works on any object, so the mass of the helicopter can't just vanish. The only way the helicopter's mass can be detected is if the rotor of the helicopter pushes air down towards the bottom of the box, so that the scale can measure the extra pressure exerted by the helicopter. These examples disprove equally well both the longer path theory and Einstein's half-Venturi theory, as they both supposedly make it possible to fly without changing the state of the air one flies through. So there you have two different examples that proves Einstein wrong. It is childishly easy. In my case, pretty literally, as I was not more than, I guess, 14-15 years old when I tried to convince that my father's stupid lift theory was wrong by referring to these examples. I never managed to convince my father. He always insisted that it was not my business to question established facts, as he put it. And it was only much later, after the internet came about, that I understood that it was not just something that he had come up with himself, but actually it was something that originated from Albert Einstein. Naturally, I am not very impressed with neither my father's or Albert Einstein's ability to think logically in this case. But how is it possible to explain how Einstein managed to get this so spectacularly wrong? My working theory is that the human brain is not really capable of thinking about more than two elements at one time. One can pretty well deal with action and reaction, cause and effect, but a fluid also interacts with itself while interacting with other objects, and therefore one needs to approach the problem from another angle than other physical problems. The more accepted explanation of how an airfoil produces lift is now that the wing simply diverts air down, thus giving it the equivalent lift. And as the pressure over the wing is less than under, the air will naturally be accelerated over the wing and slowed down under the wing in according to Bernoulli's theorem. There is no conflict between the so-called Bernoulli lift and the Newton lift here. They are both reflections of the same forces. And this lift problem is not the only misconception there exists about things related to fluid mechanics. I was thinking that this video should serve as sort of an introduction to a wider topic of how insufficient our understanding of fluid mechanics is to explaining relatively easy problems. In the next video, I was thinking to address more practical examples of how people have got fluid mechanics wrong.